Welcome back to part 2 of Module 5, Lesson 7, Equivalent Algebraic Expressions. We left off at extra example 1, and we're going to start right back at that same spot, which says use the properties of operations to determine whether or not 0.6m plus 0 and 0.6m are equivalent. If so, what property can be applied? And they give us a cool little drop-down box. Y'all take a look at those drop-downs and you figure out which one's going to be the correct answer. I'll sit here and wait for a moment. Well, the associative property says grouping doesn't matter. I don't see any grouping or parentheses there. The commutative property says order doesn't matter when adding or multiplying, and I don't see any changes in order there. The distributive property, we're distributing things through a set of grouping symbols, and I don't see that happening either. But the identity property does say that a number plus 0 is the same, and a number times 1 is the same number. Here we have a number plus 0 equals the same exact thing it was. The answer is equivalent using the identity property. Easy math. Anybody can do this stuff. Let us keep right on rocking to the next part of this lesson. And it looks like they're starting us off with another video, this time on using substitution to identify equivalent expressions.
Determine whether y plus y plus y and 3y are equivalent expressions. One way to determine whether two expressions are equivalent is by using substitution. Begin by evaluating the expressions for the same value of the variable. Choose a number, 0, and substitute it for the variable in the first expression. Then simplify. 0 plus 0 plus 0 is 0. Then repeat for the second expression. 3 times 0 is also 0. When y equals 0, the expressions have the same value. If substituting one value for the variable... Let me interrupt
for just a minute to make sure everybody understands where that 0 came from. They just picked it. They picked a number that was easy to work with and substituted it in for y to see if they got the same answer on both parts of the problems, the y plus y and the 3y. They just picked it, and you can just pick any number you want to substitute in. Let's keep going.
Indicates that the expressions are equivalent, repeat the process with a second value of the variable. Choose a second number, such as 5, and substitute it for the variable in the first expression. 5 plus 5 plus 5 is 15. Repeat for the second expression. 3 times 5 is also 15. When y equals 5, the expressions have the same value. Next, draw a conclusion about the expressions. If the substitution shows that the expressions have the same value for more than one value of the variable, you can conclude that the expressions appear to be equivalent. Now consider a different pair of expressions, 5 times the quantity x plus 4 and 5x plus 4. Start by evaluating the expressions for the same value of the variable. Choose a number, 0, and substitute it for the variable in the first expression. Follow the order of operations to simplify. 5 times the quantity 0 plus 4 simplifies to 20. Repeat for the second expression. 5 times 0 plus 4 simplifies to 4. When x equals 0, the expressions have different values. Next, draw a conclusion about the expressions. If the substitution shows that the expressions have different values for the same value of the variable, you can conclude that the expressions are not equivalent.
Well, that looked pretty easy, and I like their use of 0 because 0 is a real easy number to work with. Now, the textbook asks, why is it important to substitute more than one value into an expression to help determine its equivalency? The answer is simple. Sometimes you just have that one lucky number that you pick, and it works for both of them. But that doesn't mean that lightning's going to strike twice in the same spot. If it happens again, then you know that they're going to be equivalent. But if you get a single time when it's wrong, you don't have to work it a second time, because one wrong, one time where it says that they're not equivalent, then they're not going to be equivalent. So let's look at example 2 here. They let x equal 0, 1, and 2. So they're trying 3 different numbers on x to make sure that it's going to be an equivalent numbers. They say use substitution to determine whether or not 2x plus x and 4x are equivalent. And we're going to move through the slides to see what happens. On the first set of slides where they plugged in 0, you had 2 times 0 is 0, plus 0 plus 0 plus 0, that's 0. 4 times 0 is 0, it equals 0. But what if we were to take and plug in 1 for all those x's? You plug in 1, which is another easy number to work with, and you get 2 times 1 is 2, plus 1 is 3, plus 1 is 4, for 4 right there. And here, 4 times 1, that's 4, 2. What if you plugged in 2 for all of them? 2 times 2 is 4, plus 2 is 6, plus 2 is 8, giving us the 8 here. And then on this one, 4 times 2, well, that's going to equal to 8 as well. So with that in mind, you've got 3 different times now that you substituted 3 different numbers to check to see if it's equivalent. I think that we can therefore say that they are equivalent because they do have the same value when values are substituted in for the variables. Really easy stuff to do. It takes a little bit of supporting work, but it's not hard at all. And now it's going to be your turn. You're going to use substitution and you're going to determine, is it equivalent or is it not equivalent? Pause the video and work on this. Let's take a look at what I'm going to do. I'm going to start off by using, get my marker going here, x is equal to 0, which means for the first problem I would have 2 times 0 plus 2 plus 1. 2 times 0 is 0 plus 2 plus 1. That's going to equal to 3. But on the other side, I would do 3 plus y is now going to be 0. I guess that's just a y, not an x. Let's pretend I wrote y there. And then plus 2 times 0. So for this one, 2 times 0 is 0. So that gives me 3 plus 0 plus 0. So it looks like it's going to be good. Let's change the color of our marker and let's try a new one. This time I'm going to let y equal to 1. So for that I would have 2 times 1 plus 2 plus 1. 2 times 1 is 2 plus 2 plus 1. That's going to equal to 5 this time. If I get a 5 on the right, it's safe to say that they're going to be equivalent. So for this one I'm going to do 3 plus, now y is equal to 1 plus 2 times 1, quit it. And I see an issue coming here. That's going to give me 3 plus 1 plus 2 times 1 is 2, which is 6. Is 5 and 6 the same? It is not. And since it is not, we can go back to our problem and we can say they are not equivalent. It checked using zeros. Zeros gave us the equivalent answers. But when we tried our second number, that second number didn't work. That's why it's so important to use 2 attempts, 2 different numbers when you're checking these using substitution. Now we're going to do the same thing again, except they've given us some pretty scary numbers here. We've got 2 expressions that have the fraction 1/2 in it, and that's going to make it a little bit more challenging to do the math, but it's still totally doable. Once again, they're going to let x equal 0, 1, and 2. So let's start solving and see what happens. First off, when x equaled 0, they got 0 for an answer using both approaches. And I'm sorry, they got 1/2 here and 1/2 here using both approaches. So far, it looks like they're going to be equivalent. What if they put in 1 for x? Well, if they put in 1 for x, they've got a 2 right here and a 3 right there. At that point, you could stop, because right there you have got proof that these 2 expressions are not going to be equivalent. Let's look at one more. If they plug 2 in for x, now you've got 5 and 1/2 on the left and 9 1/2 on the right, once again, you have got proof that these two expressions are not equivalent. There was really no reason to go on to using the x equals 2 because x equals 1 already answered that question for us. Now it's going to be your turn. First off, let's see, do they have a good question here? No good question, so we're going to reset all this, and now it's going to be your turn to work a problem and see what you end up getting. Go ahead and solve this problem. It's going to be a little challenging with those fractions. Use two different numbers. I'd encourage you using 0 and 1. So let's take a look at these. First number I'm going to use is going to be 0. So I'm going to say let x, we're dealing with y here, not x. So y is going to be equal to 0, which means my first problem is going to be 2 times 0 plus 2, and that is not even the right problem, is it? So let me go back and get the right problem up here because we are not doing this one right. Get rid of that. Go back over to my other screen and copy the right problem. Paste that in. And now that looks like the right problem. So we're going to change that to a t instead of a y. So we'll just call this one here now is going to be, whoops, where'd it go? There it is. We're going to call this a t is equal to 0. And you know that means that you're going to end up with 0 squared plus, this one is just 0, plus 1. Of course, 0 squared is 0, so you get 0 plus 1, which is 1. Good so far. On this side over here, I'm going to do 1/3 times 0 plus 1/3 times 0 plus 1 plus 1/3 times 0. Now that means I'm going to get anything times 0, that's just going to equal to 0. The 1 is still a 1 there. So you end up getting what for your answer on that side? Still going to get a 1. So far we're looking good. We've got a balanced expression. Let's pick another number. This time we're going to let t equal to 1. So now I'm going to have 1 squared plus 1 plus 1. 1 squared is of course equal to 1. Plus 1 is going to be 1. Plus 1 is going to be 1. And that means we get 3 for a solution here. On this one, we're going to take and put in 1/3 times 1 plus, whoop, that shouldn't have been circled there, plus 1/3 times 1 plus 1 plus 1/3 times 1. And when we do that, we get 1/3 plus 1/3 plus 1 plus 1/3. Now these three 1/3s, they add up together to become 3/3 plus 1, and 3/3 is of course the same thing as saying 1 plus 1, which is, 2. 2 is not the same as 3, and that means that we get to go back over here and say that it is not equivalent. Check our answer. The answer checks. It's a bit harder or scarier looking with fractions, but if you're using simple numbers like 0 and 1, it really is not that bad. I think we're going to end part 2 right now and come back in just a little bit for part 3. I think we're going to have a 4-part video series in this lesson because this is a pretty intense lesson. Come back and watch part 3 where you're going to learn about combining like terms.